When you're dealing with kind of a continuation of yesterday, if we're dealing with these tables and they give us a situation like number 10, and we're trying to figure out a model. A model means a function that will help us to estimate the year. Now it says estimate the year because the function may not be a perfect cubic or quartic or linear or quadratic function. It could be we have to use quartic, cubic, or linear regression. It could be a line of best fit, so it's approximating. That's why it says estimate. So the table shows the value of Y in thousands of dollars of a signed autographed NFL football or MVP football player, where X represents the number of years since 2000. So just so we understand, number of years since 2000 is 2001, 2002, 2003, 2004, and 2005. Jacob, there's really a reason why I don't put a chair there. I mean, I don't know if you can figure out the reason. You're welcome to use one of these open seats, so we save them just for other students that are going to. You can move back later if you need to. Yes?
On number 9, I thought what was difficult was it went up in not even increments. So
yeah,
so that's not on 10.
Okay, I see. Okay, can we hit on that in a minute? Yeah. Let's go through 10 and then. That's a good point. All right, you guys, we can do this a couple ways. First, you can estimate what your polynomial degree is by finding your differences. So 6 to 34, I get a difference of 28. 34 to 162. 510 or 162 to 510, 348, and 510 to 1264, 736. Okay, obviously not a common difference, so we move down another level. There's 100. This one looks like 220. I messed up on 2 twice there. That's kind of odd. Actually, it's even. Okay, and this one is 380. Okay, and obviously not a common difference, so now we're down to 120. And looks like 168. Okay, still not a common difference. Getting closer though, right? And I mean, we'd obviously get a common difference if we do it again because there's only one. So it's most likely going to be a cubic function here. These are getting very close. It's not a perfect cubic function. Be my guess on there. So let's go ahead and plug that in. So if we go to Stat, Edit, if you have a list in there, if you go up to L1 and just hit Clear and Enter, it'll clear it if you want, or you can just overwrite it. If you hit Delete, it's going to delete your whole list, and then you have to go in and get that back another way. So I'm not. Thanks. Now everyone's hungry. Well, thanks a lot. Okay, and then we go to Calculate, and if your regression if your R factor is on there, it's obviously not linear, but if I tried quadratic and hit Calculate, I get an R squared of 0.99, 0.992, which seems pretty good. But if I do cubic, I actually get an R squared of 0.99999. I mean, dude, that's even better. Okay. If I, just so I can, I'm going to try quartic and see if that's any better. And quartic, whoa, quartic's perfect, man. All right, quartic is the one. I mean, literally, it's the one. It's got a correlation coefficient of 1. All right, so that means I've got f of x is equal to 2x to the 4th minus, now this right here, that negative 3.43 e negative 10, just so that we're clear, because I had a couple of you ask me about that. If you have, let's see if I can get it on there so you guys can see it as well. Can you see that okay? Is that pretty dark? Oh, hey, we can actually see it. So if we got negative 3.43 e, that e means times 10 to the negative 10th power. That, just so, if you've forgotten scientific notation, that means you start where your decimal is, and you move it 10 places, getting smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those places right there, I'll put the negative out here now. All those places are decimals. So we are really, really close to negative 0, which is just 0. So when your calculator spits that out like that, you just put 0, because there's just a bunch of residual junk that your calculator's calculating there. It is 0. So our b term is actually 0. Okay, so we have 0x cubed. The c term is also 0. And then the d term is negative 2. This is extra junk back here. Okay, so plus 0x squared minus 2x. And then my e term, my constant is 6. All this is extra junk as well. Plus 6. So really, we could just write it as f of x is equal to 2x to the 4th minus 2x plus 6. Okay, that's the model. Use the model to estimate the year the autograph will be valued at 5 million. That means we need to know where the value is. Is that our x or our y? That is our y. X is almost always time, and here they tell you x is time. And hold on. Yeah, it's in thousands, right? So we're saying when is our autograph 5 million? Well, you could plug it in, or you could, and that's what I was about to do, but you have this data right here. You could actually throw it into your calculator if you want. You could put it in your y equals menu. Now, if it's a big, ugly function where you had to do a bunch of rounding, I would actually use another feature to put it in, but it's not. It's a pretty easy function to type in. So I'm just going to type in 2x to the 4th minus 2x plus 6, except for that's not going to help me there. I should look up as I'm typing. Delete, 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 delete. All right. That's very frustrating. Kind of embarrassing. All right. There we go. And we hit graph. Okay, not that I'm really concerned about what the graph looks like. I really want to use the table. Because when I'm estimating what year it'll be 5 million, that is 5,000. Okay, what year will that be? Yeah, 2007 or 2008, right in there. Okay, probably in 2007 is the year it'll actually surpass the $5,000 mark. Okay, but you guys, there's a bunch of things that I just assume you pick up there. When I say 5 million, remember this is 5 million is 5,000,000. Just like 1 trillion is 1 million million. So when we talk about our national debt, think about that. 1 trillion is a million million. 16 trillion, 16 million million. Dude, a lot of cash, man. Now, let's not go into that because that could depress us. And we got a weekend coming up where the Seahawks are going to win. So, okay? Questions?
How do I get the R?
Okay, we had to talk about, I'll come over and tell you that in a while. Okay? Year 7. Year 7 is what year? 2007. Make sure we understand that as well. Okay? So a lot of different things. Okay. All right. For those of you that have forgotten how to put the diagnostic feature on your calculator, or you don't have it on, you will want it on when I'm not around. I won't be your math teacher for forever. It's sad. I know. I mean, I cry about it quite often. Okay? And some of your math teachers may not have the time in class to discuss it with you. Remember, when you leave this class, you will no longer be in a 2-year advanced class. You will be in class, like when you go to pre-calculus next year, you'll be in a class with seniors, juniors, and sophomores. So you won't be with all your groupies here. Okay? So you may not have they may not have time to go through it. You may have to reference the book more. What I'm saying is you probably should write it down. Okay? So we're going to go to second 0, which is catalog. For those of you who know this, you can just start working there on your assignment. Second 0, catalog. Notice the little A appeared up here. That means your alpha key is already engaged. If you find letter D for the alpha menu, that'll bring you down to the D's, which is just on your X to the negative first button there. And you're looking for, anyone remember? Diagnostic on. Hit enter. And then it's waiting for you to hit enter again just so you get your workout. Now it's done. Now your R, your diagnostic tool, will work. Okay? Now you'll have that R factor. Boom. Woohoo!